Good afternoon, everybody. Welcome back to lecture number 13. Today we will talk about the MATLAB and the Simulink. So always download the latest model, okay? It's a good practice. Always download the latest engineering tool, because if they, like what happened to you, if I build model using 2025B, it will not work in 2024. You have to use a certain tool to do what? What will happen to the tool? To convert it. To convert it. So this example, I copied it from where? From MATLAB itself. From MathWorks, the company itself created. So this example, how to control and initialize a synchronous machine. The test circuit shows SM operating as a generator, so we're operating it as a generator. So how many files do I have? We have M file, which is symlog needs update. We have another file, the .slx, that's the actual Simulink. And we have sm control example.m, and we have plot function. So if you go to the first one, you will notice this is just a function. Do not run a function in MATLAB, it's useless. You call a function. Clear? So this file, we don't need it. Okay? The other one is SM control. The only time you open Simulink is if you do not have data to upload on the Simulink model. So you can run it alone. But in reality, this example, we have parameters here. We have to assign certain parameters, as well as using the plot function. This is the plot function. They already made it for you. No need to have your own plots. Okay? Now, if you open the Simulink alone, it will open. So it needs some time. Be patient. My approach in this example is to open Simulink only to edit the model itself. Okay? So now we're opening it. For some reason it doesn't open. Okay, fine. So this is the Simulink thing. So what will happen to the Simulink thing? What's the problem? Any coding issue? No. So this is the Simulink model. Read. Three-phase synchronous machine control. They ask you to plot the terminal voltage and rotor speed. You have to see the code. You can modify model parameters. Then you can explore simulation results using semiscope. Here you'll find semiscope. This one, after you run the simulation. Learn more about this example. There is a whole documentation about this example. So in the homework, we asked you to see what is load A. This is not a wind farm. This is a three-phase load. So load A is rated at 24 kilovolts, 60 hertz, real power 150 kilo, imaginary power 150 mega, imaginary power 15 megabar. Okay? There is other internal components that for you as a good engineer, always use this. Always. Better than Googling the model itself. Because this, if you double click, it will open where? It will open what? It will open the corresponding model in the documentation file. And then here you read, for example, what are the components, relevant examples, ports, what it means in IOs, the input and the output. So what inputs we have? We have phase A, B, and C, and neutral, and we have one three-phase port. يعني if you pass three signal, all كلهم مع بعض, you put it here. Then you read the parameters, the electrical connection, etc. What is the rated voltage? This is a rated voltage. It's a number. It's voltage for which load powers are specified. Real power is total real power. So this is a three-phase power, not a single phase, because of the word total. Then you have to read everything else. Now, do not memorize. If you need, read. If you need, Read. If you don't understand, read. Now for three-phase model, pretty much it's self-explanatory, and then they tell you what is the virgin history. What did they make? It was introduced in 2013. Life back in before 2010 in MATLAB was very limited. MATLAB expanded pretty much after the 2015 into engineering applications. Let's go back. What is it? Okay, here. So we know now what is a load. I believe there is the Windows is still open. This window is still open. Let's close it. Now let's go to our machine. This is our machine. Read the description. Synchronous machine with round rotor, so we don't have salient pole. Using fundamental or standard per unit parameters. So this model only works with either fundamental or per unit parameters. For simulation with standard parameters, transient and subtransient values are converted to fundamental per unit. So he's telling you everything in the code is based on what? In the per unit. Okay? If you go to the setting, what's the modeling option? We have no thermal port. Sometimes there is thermal port. Electrical connection, three-phase port, composite. Many of these parameters, I don't know about them. The only thing I'm familiar with is rated power, rated voltage, frequency, number of pole pairs. Is this the American way or the British way? British way. So specified parameterization by standard parameters, and then the field, we have a field circuit, current. So here it tells you the option for the excitation. Do you want to rely on IF or EF? What's the relation between EF and IF?
Depends, motor or generator?
No, in the generator. Both. The field current will EF. Isn't it they are linear?
Yes.
Are we operating in the saturation? No, so that's what they meant is do you want to get EF or IF? Now this is the field current is 1300. Zero sequence exclude. Zero sequence is pretty much related if you have imbalance between ABC system. So if you have A 0 degrees, B 119, then you need to include. So in real life you need to include it. But for sizing, if they ask you to buy the pump, do you need to do these deep analysis? No. There is other thing, there is the time constant, QD axis. We'll talk a little bit about it. And then there is a saturation. Here we don't have a saturation. There is initial conditions. Usually initial conditions are rated conditions. Or half. Here active power is 250, reactive power is 15. Usually it's around rated. Clear? Don't change anything. Again, you can open the documentation here. What is H? Last time, do you remember we talked about the H? The inertia, what's the unit of H? هذه اللي في السلايدات.
Seconds.
No, yes, correct. This is the H. Swing equation, هذه ال H. This H, do you remember? H is called the H constant. The unit is second. Performed over M, preferred over M because it values within 1 to 10. Go here. Simulink. What do you see? In inertia, you put a power with frequency or number of poles. Then the inertia constant is 3.5. Is it between 0 and 10? Yes. It's per unit. What are the initial conditions, etc. Go to the description. He's telling you what's the description. Now, for one pole pair, the values are between 2.5 and 6. These are the recommended values. As an engineer, Ali, what to do as an engineer if you don't know what value to put?
Read about it.
No time.
Leave it. Don't.
Put the middle. If they give you a range, put the middle value. Okay? Hydroelectric. Where hydroelectric is used? Water dams. Okay? Water dams. This is what we're talking about, and pretty much leave it. If you don't know, leave it. So done with this. What is this function? Solver configuration. This is usually in MATLAB, this solves first order, second order equation. leave it. It's here meant for a reason. Usually it's put to initialize the vectors or the data. At the beginning we have these transients, so it solves it. And then this is just solver settings for use of just simulation. Don't change these parameters. There's engineers who work with Simulink who already made it for you. Now our favorite box is the AVR and the exciter. It turned out this is a submodel. You know what's a submodel? A submodel is here you have a main Simulink, here you have submodel. You can, if you go here and double click, there is one option about expand subsystem or create subsystem from selection. يعني هذا بيخلي multiple components in one box, or you can expand it. Don't expand it. You can leave it as it is. Any problem, Mr. Osama?
No.
Okay. So if you go and open the exciter, and this is homework 2, I will ask you to read about this synchronous machine AC1C. So here what you can see, we have signal 1. This is a terminal voltage. This one is what? 207 unit delay, 1 over Z. You remember 1 over Z? Do you remember it? This is just a delay. Let's use our mouse. So in homework 2, I will ask you to explore this model. What is this model? This is an asynchronous machine AC1C mask. So this block implements a synchronous machine excitation system, including AVR and exciter. So we're combining the AVR and the exciter together. Okay? For inherited discrete, no need to read more about these, but here is the general. The initial field voltage. This is EF at time 0. -1 is for inherited. This is for default setting. So put -1. It's a common thing in Simulink is to put -1 for what?
Default.
For default. Pre-control, they left it as 0. The control parameters, there is a gain. Do you remember 380 gains? This is the output time constant. This is the lag time constant. This is for A, B, and C. And here is the feedback excitation stabilizer gain. This is the stabilizer. Now, there is too many parameters. And then here is the exciter. We have also gain, time constant, lots of things. Leave them as they are. But if you don't know what to do, open help. And now if you open the help, you read more about this system. So this system is a synchronous machine excitation system according to IEEE. You know IEEE? The International Institute for Electrical and Electronics Engineering. You have to get their membership when you graduate, okay? Along with the Saudi Councils of Engineers. Otherwise, you're pretty much losing opportunities within your company.
Why do you need that membership?
You need the membership to have affiliation in case you work for Aramco and you go for conferences. You get discounted rates for the conferences and you get access to certain resources. And in your career, if you become a synchronous machine designer, over the time you will come up with your own designs, you will write white papers, etc. And then you need your membership to publish those papers publicly. It helps in the promotion with the company. Usually Aramco will pay for it, or Hadaf will pay for it. Now you have the student version. Student is cheap, 100 riyal. It's not cheap, but the professional one is $500, maybe $300. So let your company pay for it. Okay? These are the standards. Use this block to model control and regulation of field voltage. So this, an exciter has to do with the field, correct? So this is to study them. These are very complicated models. Here is the exciter circuit. And here where they are used. Marine, 3-phase custom simplified synchronous machine, and this is our example. This is our example, but I made it simple for you. So these are the inputs. For example, many of you are curious, what is the gain? What is this gain? So if you go to output gain, so this is gain associated with voltage regulator. So this is the regulator gain. Default value is 400. There is always default values to help you not to complicate things. The exciter, what is the job of that? So we have AVR. AVR changes EF, right? The exciter, exciter changes what? Do we have frequency control here?
No.
No, not here. So the AVR is the automatic voltage control, and the exciter is the excitation circuit itself. But I will show you the exciter commands here. If you go back to MATLAB, goes to the field circuit. So the output here, the field command, would go to the excitation circuit. So this is synchronous machine field circuit. So what is this? This one, اللي هو الفيلد circuit, is connected to it. This is for electrical reference. So this is the one that gives you IF. What's the output? IF. You put EF. What's the output? IF. And then you have positive DC, negative DC. You feed these two terminals where? To the machine in positive FD. So this is the AVR and exciter together. Inside this model, it takes care of the exciter as the AVR. What is automatic voltage regulator? What's the job? To maintain the voltage of V terminal. What do you notice about that? We're getting signal number 1. So this is V reference. 1 is what? Is this a constant? No, this is a constant. So this is 1 per unit. It means stabilize, make AVR to 1 per unit. Clear? So in the homework, maybe we'll ask you to change the regulator output gain to 200. See what will happen. Change the exciter field time constant to 0.3. Make it slower. Okay? Again, if you go back to the help page, it tells you all of these parameters. If you notice here, what will happen is we have V terminal and I terminal. We have current compensator. We get VC1. We have voltage measurement transducer. We compare it with the reference and VS. This is excitation control element. We get IF. Then we have the exciter itself. And then we get EF as in, this is DC component. And then we get feedback reference. So these are complicated things. This is the block diagram. I highly recommend you to just try. I myself don't know them. I don't know all of these. This is how they model it. Clear?
Yes.
This is what's the job of this? This is just, it gives you, if you read about it, this is the synchronous machine field circuit. So this is nothing but a circuit. So this is a applies specified voltage to measure current through. Its purpose is to what? Its input is EFD, which is field voltage, either per unit. And what's the output? Field winding, positive terminal electrical, negative terminal. This goes to the machine. And these are the parameters, rated, frequency, etc. So, homework 2, you will be exploring these. Why do we have a delay here? We have a delay here to allow the field that we're taking it back as a reference to have some time. If you put this as 0 delay, then what's the reference? You don't have a value. So you always take the previous value. What's the delay? It's 1.3. What's the unit? I think it's...
Second?
No. The delay is the previous sample. This is digital. This means take the previous sample. This is initial condition. I don't care about it. I care about this sample type. If you put, for example, other values in the delay, if you put, for example, sample time, discrete interval between sample time hits, the default value is -1, which is 1 sample. If you put 5, it means you will wait for 5 samples and then take the field after 5 samples. this is a bus, I think. This is terminal voltage. So this is calculate synchronous machine per unit measurement. Actually, this one is a synchronous machine. And what is this value? This is port number 1. From where we get port number 1? Where do we get it? Question in the exam. This one, from where it comes? This one goes to VT and IT, صح?
Yes.
من وين we take VT and IT?
Stator.
Right. We get it from the state of the machine. So we're taking VT, IT. If it's 0.9, what the AVR will do? Try to do the control to bring it back to 1. If IF increases, decreases, it will take it also as a reference, and in this mathematical model would do the phasor diagram to correct E if needed. Clear? Your job is to have VT always 1 per unit. If it's not 1 per unit, it means we have a huge problem.
Doctor, why do you have a bus in the EVR inside?
This bus,
Yes.
and I think, if I'm not mistaken, this to make a connection, splitter, this is like a splitter. I think this is a splitter. I think this is a splitter. يعني it takes the 3-phase measurements. It gives only 1 VT per unit. But this is a splitter because you cannot. So this is L connection 1. What is this? This is array. So I think this is a splitter because you're getting only 1 signal here. From here you get voltage and current. So this is the, if you here you get the voltage, here you get what? The current. Because then the output is mixed, the data is all together. So this one is a splitter. I don't know, I could be wrong. Okay? And then you get it, feed it to the AVR and exciter. What happened? متى انقطعت الشاشة؟ تو؟ وربي. Network error. 10.59.15.117. Okay? No, wrong. 10.59.15. What's happening? Okay? Clear? So now we fixed the model in homework 2. We changed the gain. Maybe we changed 3 or different things. What should we do? Nawab, is there an issue? Please let me know.
No, everything's good.
Yeah, let me know if there is an issue, okay? So let's say you finished changing the AVR. Maybe we change the, I don't want to change it. But let's say you change the 400 to 200, okay? Then what should you do? Save. You should save your model. Be professional. Should you hit run? I don't want. Why? لأن أنا عندي reliance on the code to load some parameters. I don't know what are those parameters. It may work now, but I don't want to double create them. I want to follow the procedure. So I close the Simulink. And then I go to the example. This example would do what? Would open Simulink for me, would open the file, and then would assign parameters. The find all, make it on, the tags, the features, etc. Also, it will call the plot function and plot everything. This is my main function. So, to do the homework, you should have gone to this file, which you should do today and submit, okay? Submit. Who did not submit the code because of this problem? So go today and submit, okay? We're here to learn. Try to run it and submit your code. Anybody didn't submit the homework code? Do it today, okay?
Doctor, do you want the MATLAB file?
Of course.
But
Well, you don't have to, but
It's already graded يعني.
that's okay يا أخي خلاص. Instead of 0, instead of 6, you will get 10.
So we run the code and put the output.
Yeah, but email me that you submitted late, okay? Email me that you submitted. Okay? Send me email so that I go myself and regrade your homework. Please do this. We are here to learn. Simulink is very important. So let's say, and tell your friend, okay? So let's say now we finished that how to run the code. It's very simple. Go to the editor. I usually put CLC, clear all, close all, and then I go here to run. So now it will do everything for me. It opened the Simulink. So this is Simulink. So what should I do? Is I should maybe, okay, these are the plots. So this is the terminal voltage 1 per unit, and this is the rotor velocity in per unit. So rotor velocity is 0.98. So it oscillates only 0.03, lowest point. So this plot from where it came from the function plot. Close it. Put it in the homework, okay? Then it asks you to go to Semiscope. Semiscope, why I like it? Because it gives you access over all the modules in a hierarchical manner. So here you have the AVR and exciter. So in homework 2, maybe we'll go explore the field. So what do we see here? We see here EF. What is EF? EF is maybe it's 1.8. What is IF? How come the IF and EF are the same values? So here the simulation is 15 seconds.
Per unit maybe because.
Okay, this is I and I0. This is nothing per unit. You go here. So this is EF D and this is IF. Okay? Because they are linear. Makes sense. Because if it's 2 per unit, this will be 2 per unit. And a linear. That's why. What is this frequency? No, not frequency. This is the velocity, 0. Some parameters are useless. Yeah. There is I, there is I0, there is the terminal voltage. This is the input, this is the output. You don't need to get everything. So electrical reference 1, electrical reference 2, electrical reference 3, then the governor and the prime mover. This is another model. And then the loads and the machine inertia. I asked you in the homework to plot this and that. So go here in this curve. Now some students would screenshot. Professional students, what should they do? They go to export figure, and then they go maybe either copy. You can copy figure, but they save it as PNG. PNG is the professional way, and then once you save it as PNG, there is the PNG. It will be in your files, okay? It will be in your files, and take it. Or you can use print and save it as PDF. Or if you don't have time, screenshot. Who cares, okay? For the homework, you can do screenshot. So this is the Semiscope, and that's it. When you finish, what should you do?
Save.
No, you don't need to save, because we did not change the model. You save only if you change the model. Close it. Close it before you close the MATLAB. But we cannot close it. Why? Because we have certain, I think we have this figure here. And then you can close this here. Okay, now it's, why it doesn't want to close? Okay, where to save the figure? Let's save it in the downloads. Something is wrong. And then you take the figure in the download. Okay, figure 1. Where to look at? Figure. Something like that, okay? Clear?
Yes.
Where is the Simulink? I think it's closed. It's closed. Can quit it. Where is the MATLAB? Okay, we quit everything. So any question about it? What time is it? 46. So we didn't have a lecture today. Anyway, do you want an online lecture on Thursday?
ليش عشان السفر؟
No, I am not gonna be.
Okay.
Or do you want to come to class with the team? Raise your hand if you want online lecture and I do it. On Thursday. Okay, so on Thursday, so you do want in person with the TA?
No.
Okay, so online lecture on Thursday, okay? We'll have an online lecture on Thursday. So if you want to have plans, you can leave before Ramadan. Is it before Ramadan? Or we have one more Thursday before Ramadan?
اتوقع الاسبوع الجاي.
This is the last Thursday before Ramadan. So let's make it online. I have trouble. So don't come to class on Thursday. Okay? Tell the group. Tell the group. Okay? Any other question?